Hey guys, this is Mr. Lowry. This is some help for this assignment here that's called similar triangles. I'm going to walk you through it a little bit and then maybe do a few of the problems on here. I also have some other spare examples just because there's not so many here. I don't want to do them all for you. I want you to have a chance to practice. Okay, but let's go ahead and start with this first section here. Okay, so you have 6 problems in the first section. They're all going to be relatively similar. The idea here is that the triangles that they're giving you are similar, and we're using an idea about similar triangles to set up and solve proportions. Okay, so if 2 triangles are similar, then their sides are proportional, which means that they're in the same ratio, or you have equal ratios. So we're going to practice setting up proportions and solving for missing pieces here. Okay, so that there's several on here, but there's notice only a few different kinds. You have a couple where the triangles themselves are actually kind of separate. You have a few here where they're like kind of overlapping each other, so you have like a little triangle within a bigger triangle, and then you have these kind of like bow tie shapes here. So if you kind of figure out how to do like one of each, then the rest of them, it's not too bad. Another thing that you really want to pay attention to is this statement. The order that the letters are written in will help you line up the sides the right way. Okay, so these problems here, this is your actual homework assignment. What I want to show you is some other example problems that are similar, but not exactly the same, because like I said, I want you to be able to practice, and there's only a few of each kind. So this one I believe I did in another video. Let's run through that one real quick, and I'll help you set it up, and then if you want to skip it, I'll do the other 2 in a second. Alright, so this is everything. Okay, this statement is really what's going to help you, the similarity statement, because it tells you how to line up your vertices of your triangles. Okay, so notice that we have a couple sides here and a couple sides here on these two triangles. They have to be in proportion. So what I would do here, before I do anything else, I would just take this statement and write out a proportion. There's going to be 3 pieces to this proportion. That's okay. I know that QR corresponds to QC because they're in the same position, right? First and second. So I put them in a ratio. Okay, I know RS corresponds to CD. So I put them in a proportion. Okay, and I know that QS corresponds to QD. So I put them in a proportion. Then I just figure out which ones I actually have. Okay, so I have this guy, QC, right? That's 10, this guy. And then I have QR, that's X plus 1. Okay, I have QD, this guy. Okay, that's 22. And then I have QS, which is this guy, 33. I don't have this one or this one, but it doesn't really matter. So this is the proportion I'm using. Okay, that's the hardest part. Once you have the proportion set up, you just solve it by cross multiply. So multiply across this way, set that equal to this, and go from there. Okay, if you wanted to simplify this to start out with, you can do that as well. Okay, I already did that one in a previous video, so I'm going to leave that there for now, but that's kind of the idea. Let's take a look at this one. Okay, now this one's a little different because it doesn't give you the statement, right? It doesn't give you the similarity statement. But you actually don't need one because it's already lined up. J corresponds with itself. JE corresponds with JL, and JD corresponds with JK. So here the triangles aren't in the same position, but here they are, and so you kind of set it up that way. Okay, so notice we have a little triangle living inside a bigger triangle. Okay, and the 3 sides of the little one are the 6, the 8, and the x minus 3. The sides of the big one are the 36, the 60, and the 48. Okay, so let's set up the proportions, right? So this guy, DE, corresponds with KL. So 8 over 48. Okay, I'm setting up a proportion. Now, be careful that when you set up your proportions, you do it in the right order. So right now what I'm doing is I'm going small to big. Okay, so anytime I write a small side, it should go on top, and anytime I write a big side, it should go on the bottom. You don't have to do it that way, but as soon as you make that first decision, you have to match all the other ones. So I could have just as easily done 48 over 8 as long as I kept that pattern going. I'm just going to leave it like this for now. Okay. So if these triangles are similar, I should have proportional sides, right? So let's go small to big. 6 to 36, right? Okay, 6 over 36. Okay, and that's going to give me, the last one is x minus 3 over 60. Okay. Now these two guys actually will simplify to the same thing, and if you want to simplify those from the get-go, you can do that. They're both 1 over 6. Okay. And then you just solve this proportion with cross-multiplying. That's not the only way to solve it, but it's kind of the standard way. So there's multiple ways of going about this. Okay, so 1 times 60 is 60. Cool. All right, and the other way, 6 times x minus 3. Make sure you're distributing here. So 60 equals 6x minus 18. If you add 18 to both sides, it looks like we're going to get 78 equals 6x. Okay, and then we'll just divide it out here. And I think that's going to be 13, but let me double check here. So I misplaced my calculator, sorry. Yeah, 13. Okay, cool. So you didn't have a similarity statement here. That's okay. You can still set it up because the orientation makes sense. So let's take a look really quick. Go back at your assignment here. So we just figured out how to do these guys. Okay, you have a triangle living in a bigger triangle. So matching up the sides is, relatively easy. 16 over 52 should equal 32 over 14x minus 8, which should be the same as 36 over 117. Okay, and just solve that proportion. Now you're going to have you have 3 sides, right? You don't have to use all 3 sides. Like if you go back in this one right here, had these sides proportional to these and proportional to these. The ones that don't have a variable should be the same, right? These are both 1 over 6. So you could take your pick. You don't have to use that one. You could just use that one. It's 1 over 6. So just pick 2 of them. One should have 2 numbers. The other one should have a variable and a number. All right, so now we know how to solve these. We did like the bow tie kind, I think. Yep. So let's take a look at this guy. Again, this is not on your worksheet. This is just a practice one. I just printed out some extra examples. Okay, but again, this similarity statement is what's going to help you here because it's hard to see what matches up. So FE is going to correspond to AB, right? So I'm going to put FE over AB. ED is going to correspond to BC. So I'm going to put ED over BC. Okay, and then FD, the third side, is going to correspond to AC. And what I'm using is the position of the letters, right? So if 1 to 2, that's FE, that has to match 1 to 2 for the other triangle. Right? 2 to 3, ED, that has to match 2 to 3 from the other triangle. Okay, so this is my proportion. Now, again, I don't have to use all 3 of these. In fact, I don't have all the information to use all 3 of them, so I just figure out what do I do have. Okay, here's AB, it's 45, right? FE, right here, that's 10x minus 13, okay? Looks like I also have AC, so that's this guy, right? That'd be 45. Oh, sorry, AC is 50, excuse me. And then I also have FD, this guy, which would be 130, okay? And that's not the only way to set up the proportion, but because you could have them flipped if you wanted to, but we're basically going to put corresponding sides in ratio to each other. So find the corresponding sides and put them in a ratio. And also, from here I went like first to second or top to bottom. So if you go top bottom, then you should have top bottom on the other spot as well. Okay, so my proportion is this. Now you could solve it from here if you wanted to, but Also notice these are both divisible by 10, so it might make your life easier to do it this way. So 5 times 10x minus 13, going this way, right? This times 5, because I canceled out the 0, equals 45 times 13, going this way. Okay, distribute 50x minus, let's see, that's, I think it's 65, equals, okay, I don't know this one. 45 times 13 is too big for me. Okay, 585. Okay, so 50x equals, if I add 65 to both sides, it's 650. Divide both sides by 50. Sorry. Okay. Oh, 13 again. Coincidence. Okay, so that's like one of each. So these guys that you're going to do, right? Same thing. You got to start by matching up the sides, okay? If you have a similarity statement, perfect. That's what's going to help you out a lot. The middle two don't, but that's okay because the way they're lined up, it makes it super obvious, right? Obviously, LK corresponds to BC, and then DB corresponds to DL, and DC corresponds to DK. All right. Okay, the next couple here. So the difference between congruent and similar, congruent triangles have congruent sides and congruent angles. Similar triangles only have congruent angles. Their sides aren't congruent. Their sides are proportional. Okay, so that's kind of the idea there, but you can put that in your own words. Okay, SAS congruence and SAS similarity. SAS stands for side angle side in both cases. The difference is here, just like we talked about up here, the sides for congruent triangles need to be congruent. The sides for similar triangles need to be proportional. Okay, that's why we set up those ratios. Okay, similar down here. So the whole idea is, are your sides congruent to each other or are they proportional to each other? Okay, similarity goes with proportional sides. Congruence goes with congruent sides. Okay, but for both similar and congruent, the angles are the same. The angles are congruent. Okay, if you need to look up, these things here in your book, you can do that. Go back to chapter 5 for side angle side congruence, and then chapter 6 is side angle side similarity. This is actually in 6.3, 6.3, and these are in chapter 5. So kind of write those out in your own words, but that's kind of a key idea. Okay, on the back side, now this is your worksheet again. Okay, we want to determine if the triangles are congruent. Okay, not congruent, similar. I keep getting those words mixed up. So we're determine if they're similar. Okay, now there's 3 options here, right? Angle, angle. If 2 angles of one triangle are congruent to 2 angles of another triangle, the triangles are similar. Okay, we have SAS similarity, and then we have SSS similarity. Okay, remember sides are proportional here. So let me give you some examples, again, not from your worksheet, to kind of help you out, because there's only 6 of them. So if I did, several of these, then you wouldn't have enough to practice, and I want you to practice. But you'll notice there's a couple different kinds again. You got like the bow tie kind, you got the kind where the shapes are separated, and that's kind of it. So let's take a look here. This is not from your worksheet, but they're similar. Okay, so in this figure, notice you got parallel, right? Parallel. They're marked parallel. If you have parallel lines cut by a transversal, that gives you alternate interior angles. Okay, so angle C and angle K are congruent by alternate interior angles. Okay, also we have these vertical angles here, right? So angle LDK is congruent to angle BDC. And that's all we need. That's as much as we need to know to say, because that's 2 angles. Now we could also say that angle B is congruent to angle L, also by alternate interior angles, but we really only need 2. Okay, so we want to say if they're Triangles are similar, they are. If so, state how you know they're similar, and then complete the similarity statement. So let's start with the similarity statement. So DCB is congruent to DKL. And remember that the order of the letters is important there. So you want to line up the corresponding vertices and angles. So since C is congruent to K, they're in the same position. Okay, we're going to put by AA, right? Angle, similarity postulate. Okay, now if we're showing our work, then probably what we want to put, a habit that we've gotten into, is saying what else we've been using. So let's go ahead and write vertical angles theorem. That's how we got those guys. And let's write like angle C congruent to angle K, alt, int, angles. So that'll kind of demonstrate that we actually know what we're talking about and why we got those. We're kind of showing our work, showing our thinking there. Right? So that's pretty complete. Okay, so that's an example of how you can show that two triangles are similar by AA. But there's other options, right? So I have one of each. So AA, check. Let's do one with SSS. Okay? All right. If two triangles are similar, sorry, I think I said congruence again. We're talking about similarity here in this worksheet. Similar. Okay. If these two triangles are similar, then their sides need to be proportional. Okay? So what we want to do is we want to set up proportions and just make sure that those proportions are actually true statements. So what I'm going to do here is I'm going to start with one triangle, and I'm going to list the side lengths in order, 6, 7, 10. You don't necessarily have to do it in that order, but it helps me to keep track of them. Okay, now I'm going to list the side lengths of the second one in the same order, like shortest to longest. So 36, 42, 60. Okay, now these should be ratios, right? If these are actually similar, then the sides should be proportional. So we should have equal ratios. And since these all equal 1/6, that is true. And so we do have congruent triangles here by SSS. Okay, we just got to make sure we line up the vertices. So if I go, ABC, or sorry, RST, so RST, notice that when I go in that order, I go across the short side, and then the long side, and then the medium side. So when we line up our vertices, they need to be in the same order. So short to long to medium. Okay, that would be short to long to medium. That would be ABC. Okay, don't assume that you're going to go in alphabetical order because it may not be the case. I use the length of the sides to order the vertices. Okay, number 3. Okay, so notice that, let me go back really quick. Showing your work, this is how you're going to show your work, right? I need to see the proportions. Show me that you're setting them up the right way. Now, a lot of times people will write this on their calculator and they'll verify on their calculator, but I want to see the proof on your paper, okay? Also, I needed to add that these are similar by SSS, okay? So, show your work, make sure you include everything else you're using. Okay, number 3, notice we only have 2 sides for each one, but we have this bow tie shape again, so we got vertical angles. So I'm going to do vert angles theorem. Okay, mark that those two guys are congruent. All right, so now I have basically side angle side, but I can't just say side angle side because I don't know these are proportional yet. We have to test it, right? Like in this case, if these weren't all 1/6, we couldn't say side, side, side. You can't just look at it and be like, oh, I have 3 sides and 3 sides. It must be SSS. There's a possibility that the ratios don't come out the same, in which case they won't be similar. And the same thing is true here. So we got to line it up and, kind of make sure that these things are actually in proportion. So again, let's do the lengths of the sides. So for the first one, I got 24 and then I got 44. Okay, now I'm going to do these guys. So the shorter one is 6 and the longer one is 11. Okay, those should be equal. If they're not, even though it looks like you have SAS, you don't actually, because they have to be proportional. Okay, but this simplifies to 4 equals 4, or 4 over 1 equals 4 over 1. So we're actually good here. Okay, so we have side, angle, side, and the sides are in proportion. So this is actually true. So L, M, N, right? So I'm going across like this guy, the long one, and then the blank one and the short one is going to be similar to L, C, D. I got to go across the long one, the blank one, and the short one by SAS. Okay. So that's one of each. Now, again, let's say I set up this proportion. Let's say I had this exact same thing, except this wasn't a 6. Let's say it was like an 8. Okay. If that was the case, it would still kind of look like I had SAS, but this would come out to 3 equals 4, which is not a true statement, right? If I had 24 over 8, that would be 3. So you can't just see that you have the right, like the numbers. You actually have to test the proportions, set up the proportions, and make sure it works. And if it doesn't work, then you say there's not enough information, or you can't say that they're similar. Okay, so those are 3 examples that aren't on your worksheet. Okay, this is your actual worksheet, but you're going to do the same kind of things, right? So notice you got parallel sides, so you're going to have some angles that you can grab out of there. Okay, on this one here, you have 3 sides and 3 sides. So you can't just say side, side, side right now. Yeah, you have 3 measurements and 3 measurements, but what the key is you have to see if they're proportional. You have to see if the ratios are actually equal to each other. You have to test it. Okay, here it looks like you're going to have SAS, right? Because you have the vertical angle, but you got to set up the ratios and see if it actually works out. Now, this one's pretty obvious because the numbers are kind of the same there. Okay, same thing. You got 3 sides. Same thing as this one. You got 3 sides and 3 sides. So you can't just say SSS. You got to set up the proportions and actually verify that they're going to work, because they may not. Okay, SSS here, but again, verify. Set up the proportion, verify it. Okay, and then this looks like it's going to be another SAS. Okay, you can assume that these are congruent by vertical angles, but probably write that so you're showing your work. Okay, set up the proportions and make sure that these actually work out. Okay, that's how you're going to do that guy. So without doing too much of your assignment for you, hopefully that's enough examples to kind of show what we're talking about here. But really the idea is all about proportionality, which is why we spent a big chunk of our lesson talking about solving proportions and what proportions actually mean. Okay, I hope that helps you and kind of gives you a head start. If you're really struggling with this and you're still having a hard time, shoot me an email and we can maybe set up a time to have a Zoom call together to go over some that you're struggling with. Thanks.